Hi there, welcome to my course. In this lecture, you will learn about vulnerability identification. Active scans. There are two messages that we use within ICMP to determine whether our target is alive: echo request and echo replay. An example of the ICMP echo or echo replay message can be seen in the figure. The initial request from our attack system will set the type field to 8 and send the datagram to the target system. If the target system is configured to respond to echo requests, the target will return a datagram using the value of 0 in the type field. It is possible that systems are configured to ignore ICMP requests to provide some protection against random scans from malicious users, so results are not always accurate. An example of a successful ping request can be seen in the figure. We see that 64 bytes of data was sent to our target 3 times, and each time the target replied. Additional information is provided, including how long it took to obtain a reply from the target. As a side note, Linux and Windows handle ping requests a bit differently. One of the biggest differences is that Windows will tell us when a packet is dropped, whereas Linux won't tell us until we cancel the ping request. Another one is that Linux will ping forever until actively terminated. The only reason we received just 3 ping packets from our target using Linux is because I stopped it at that point. Latency information is useful for adjusting the speed of your attack, but not very helpful for the purposes of verifying availability of a target. Let us take a look at the figure, where we send another point to a different target. But this time the target system is blocking all ICMP traffic. The figure shows that 24 packets were sent to the target system and no echo replies were received in return. If we relied simply on ICMP to confirm the existence of a system, we would have missed this particular server, because it is possible that ICMP messaging may be disabled for 192.168.1.100, and alternate tool should always be used to verify our findings. A tool we will use extensively is the Nmap port scanner. Nmap is short for Network Mapper and is a open source project available from www.nmap.org. If we are not connected to the network segment containing our target system, we can use Nmap to try and detect our target. This figure shows the result of an Nmap ping scan. We see that Nmap was able to detect our target, although our previous ICMP echo request was unsuccessful. Passive scans. When we are on the same network segment as the target or in the path of the packet, we can listen for network chatter to detect systems. The advantage is we do not have to send any data packets, allowing us to be less obvious about our intentions. This figure has the results of network traffic on my lab network. UDP scanning. UDP scanning has many disadvantages. It is slow when compared to TCP scans, and most exploitable applications use TCP. In addition, UDP services only respond to a connection request when the incoming packet matches the expected protocol. Any UDP scan has to be followed up with connection attempts. Despite the disadvantages, UDP scanning is an essential component in target verification and understanding the target network.